Which is better, simple or compound interest? We are now going to conclude exponential functions with this video of which is better, simple or compound interest. So last thing we're going to look at before we start comparing linear and exponential functions. Here's a reminder of what your notes should look like to take notes from this video. Let's begin this lesson by comparing simple interest and compound interest. So this is them being compared to each other, and also the description of each. For simple interest, it's interest earned on the principal investment. So you might be thinking, okay, what is principal investment? The principal is the original amount of money invested or saved. So if you have some money and you want to invest it, or if you want to save it, then that's called your principal amount, your beginning amount, your starting amount. So simple interest, you earn interest on the original amount. However, for compound interest, you're earning interest on interest. Some of you saying this word a lot. It just sounds funky to say it so many times. But for compound interest, you're earning interest on interest. So let's say you get 6% one year. The next year, you're going to get 6% on a whole new value. Remember that example we looked at when we talked about earning money for a raise was 6%. So you would earn 6% on your new wage for each year. And that grew, that number of how much money you were earning from your job was growing exponentially. That was an example of compound interest. Let's focus on simple interest first. And this is an equation of simple interest. And this is actually your step one. So make sure you pause, write everything you see on the slide, and then begin when you're ready to follow along with me. And this is really funny. I was tutoring a student, and I asked him to take out his notes to help him. And he took out his notes and said they don't really help. And I asked, well, why don't they help? Don't you pay attention to what I'm saying in the video? And he's like, no, I just write down what's on the screen. You guys, that's not active listening or engagement within the videos. So you want to write everything down and then go ahead and resume the video when you want to follow along and add additional things that I'm saying into the notes. Try to really understand what I'm trying to explain. So for our first part, we're going to look at simple interest. The principal is the beginning amount. You multiply, and if you don't know what this X meant, this is something that I wouldn't need to do because I know what that means, but if you don't know what that means, you should write this is multiply. Then we're going to multiply by the interest rate, okay? So you want it to be the actual rate. We're going to need to change that rate to the percent if we're going to use that to multiply. And then we're going to multiply by the time period. It could be generally within years. And it could also be within months, but you would probably have to take a fraction of this into years. And this is going to equal the interest earned, so how much money you can earn. Now, this can also work kind of backwards where you're gaining interest on a student loan, which is what I'm currently doing now. So let's take a look at an example of simple interest. We have $1,000 invested. That's our principal amount. Our rate is at 7%, so we use that percent and write it as a decimal. And our time period is for 5 years, so we put in just 5 since we're talking about in terms of years. Then we multiply all these together and we get $350. So that is the interest that is earned on something that is $1,000 with 7% for 5 years. This is how much money you would end up making from that investment, or if you're putting this into a savings account. This is only step one. Let's take a look at what we need to do next in order to find out what our total amount of money earned is. Okay, so here is step two. Now, once you have found what the interest is earned, oops, I did not mean to do that right here. Remember, we found out that this value was $350. Well, now we're going to add that amount to the principal amount, and now we get the amount investment is worth. So what money are you walking out with? What are you making at the very end? So if you take $1,000, then you add that to $350. This is what you have. So you took $1,000, you put it into account. It earned 7% interest rate for 5 years, and at the very end, combined, you have $1,350. Very nice compared to this amount here. Okay, this is a lot of information on the slide. For this word problem right here, you are welcome to just write down what the most important information is. We will highlight and underline the important information. And then make sure you have all this work down, and then I'm just going to go ahead and talk through it because you have it already there. Now you can really follow along and see, okay, what does this number mean? What is she doing here? Why is she doing it? Okay. Let's begin by reading the example. To buy a car, Jessica borrowed $15,000. So this is an example where you're borrowing money. She borrowed $15,000 and she did this for 3 years. 3 years at an annual means each year, annual simple interest rate. And the simple interest rate is 9%. So I'm going to circle that, and that 3 because those numbers are very important. So how much interest did she pay? How much interest will she have to pay if she pays the entire loan off at the end of the 3rd year, which is why it's going to take her 3 years. So let's, last part is, what is the total amount that she will have to repay? So what is the total amount at the very end of this loan? So she borrowed $15,000. That sounds like a great amount to have to borrow for a car. She did this for 3 years. Okay, for 3 years, it took her 3 years to pay off this car. And the rate is going to be at 9%. Okay, so that's 9% of this money that she's going to have to owe. But this is spread out over 3 years. Okay, so to do this, we're going to use the simple interest. That is the principal amount, the interest total is equal to the principal amount times rate multiplied by the time. So the principal amount was $15,000. Her rate was 9%. We changed it to a decimal, 0.09. And the time it took for her to pay this loan off was 3 years. So now the interest rate is $4,050. So that is 9% of $15,000 over 3 years would be $4,050. But we're not done, right? Because we want to know what is the total payment on the loan. What is the total amount that she will have to repay? So it's not just that she'll have to pay $4,050. That'd be awesome. Then you borrow $15,000 and then you only have to pay $4,050. But that's not what they're asking. They're asking what is the total amount. So guess what we'll have to do next. Hopefully you guessed this correctly. You're gonna have to now add the total amount, which was $5,000. I hope you can see that. There we go. The total amount, which was $5,000, I'm going to add that to the interest that we have gathered off the loan, which was $4,050. So the total that she has to pay is $19,050. So you really want to think about it. Do you want to go ahead and borrow a car or purchase a car, borrow $15,000, or you can purchase a laptop, anything with that money, but over 3 years at 9%, are you ready to pay back the $19,050? Let's check out a second example. This is example for TJ, who invested $4,000 in a bond. So this is the other way. TJ is not borrowing, but instead he is investing his money in a bond at a yearly rate of 2%. And he earned $200 in interest. Okay, so this looks like we might have to work backwards because they told us how much he earned in interest. He earned $200 in interest. So how long was the money invested? Oh, okay, so we're looking for how long was the money invested. Now, looking at all these variables, which one do you think we need to solve for? And hopefully you have identified that it's T, which represent years. We need to find out how long he had this loan for. So let's plug in all the known information. We know that it's $200. That was the interest that he earned, so it was there. The principal amount was $4,000 that he has invested in a bond. The rate is at 2% for each of those years, so we can just put in 0.02. And now we're looking for T years. Let me box that one, okay, because that one's special. To do that, we will multiply these two numbers here, the 4,000 by 0.02, and get 80 T. And then we'll divide both sides by 80, and we would get T equals 2.5. Remember, this is talking about years, so it would take 2.5 years or 2 years and 6 months for TJ to have $200 extra from the $4,000 that he invested. Now let's take a look at compound interest. We now looked at simple interest, and we noticed that if you just go ahead and invest one amount or borrow one amount, and then over so many years it's going to have the same fixed rate, then you would have simple interest. But now let's take a look at compound. There are two methods for calculating compound. One method is single sum of money, is invested only once at the beginning of an investment. So you just put this money away, and then each year it's just giving you a new, it's putting on the interest rate, and you're gaining more interest. Or it could be equal number is interest spread over time. So that means equal amount of money are invested multiple times. So let's say you're going to take $1,000 and you're going to do it 4 times a year, or you can invest it 3 times a year, or twice a year, or once a year, or you can do it every month of the year. We're going to look at examples of mostly number 2, but you'll definitely want to keep in mind number 1 as well, and we'll look at one example of number 1. Okay, the compound interest equation is a little bit more complicated, and we actually have to use exponential functions, which is why we've been learning exponential functions for a couple weeks now. Here we have the equation that you would use, okay? So you may want to box that or circle it, and now let's define each variable. P is the principal amount, just like in simple interest, same thing for compound. You're going to have your interest rate, which is R. That's the same thing as simple interest too. But in this case, now we're going to add a 1 to it because we're growing here, okay? You're increasing. So we're going to go ahead and know that this is growth right away for an exponential function. So we're going to add 1 to the rate. And that's going to be here. And this becomes your actual factor, your exponential, your growth factor. So let's write that down. This is your growth factor. Is what we used to call B. But instead of putting B, we put the 1 plus R because we already know that it's going to be 1 plus the interest rate for growth. And then N is going to be the time periods. So that depends. And we're going to take a look at a slide where it explains different time periods you can have, because it could be a year. You can invest money every month. You can invest money twice a year. You can invest money 3 times a year. And there's specific names that we'll need to follow. And then after you're done plugging all that information in, you'll finally get the amount investment is worth. So after I invested all this money and these different times each year, how much is it worth? So let's take a look. We have $1,000 invested at 7% interest rate compounded yearly for 5 years. So every year you are investing $1,000 and you're gaining a 7% interest rate on it. So to show that, we take 1,000, which is 1,000, which is the money, the principal amount, the amount originally invested. We take 1 plus the rate, which is 0.07. This is 5 years, so it's to the 5th power because we're working in years here for N. And there you would get $1,403. So this is our total investment is worth. It's worth that much money. Now that we've looked at an example of using this type of equation, I want to discuss one other equation. And that's for the second situation that we were talking about. What happens if you have the situation number 2 for a compound interest? And that is when you are investing multiple times in a year. It could be, it can even be yearly, but it would be very specific type of example. So for that equation, it will still be principal times 1 plus, but instead of R, we're going to do R all over N, instead of just having the R there. And we're going to go to the N power, but then we're going to have to put in T, which is going to give us how long it's going to take. So this is a modified equation that we're going to have to use. And this is going to be for situation number 2. And we're going to focus on situation number 2 for some examples. This was for situation number 1. Notice how it said it was just compounded yearly for 4 or 5 years. So we can use this box formula for compounded interest. And now we're going to look at how we can use the one that's a little bit more complex. Okay, before we look at any other examples, let's discuss what happens if it's compounded with different amounts of time. So if it's compounded annually, That means 1 year. So that one was compounded. The last example we looked at was compounded annually, but it was for 5 years. So we just plugged in 5. Semi-annually is 2. Quarterly is 4. And monthly is going to be 12. So if you're going to go ahead and put money in semi-annually, you'll put in 2 for N right away. Or if you're doing it quarterly, you'll do 4 because you're going to do it 4 times in a year. That was quarterly means. And monthly means you'll do it each month, so that's 12. Here's an example of that type of that second type of compound problem. Here, David invested $1,800 in a savings account that pays 4.5% interest, compounded semi-annually. Remember, semi-annual is 2. Find the value of the investment in 12 years. So this has to be after 12 years. Here we're going to take here's our compound interest formula that we will need to use. We have 1,800, that's the principal amount. 1 plus, I do not know why there's a T there, but ignore that. That must have been from the other slide, or from the PowerPoint. So then we have our rate, which was 4.5%, and as a decimal 0.045. The interest compounded semi-annually, so N is 2, and N will also be 2 here. And then our time is going to be 12 years. So our T is 12 years because they said that the investment is going to be at the value of the investment in 12 years. They want to know what's the value of this investment after 12 years has passed. And because it's semi-annually, that's going to be N. That gives us the number of times that it is invested. Then we are going to simplify this by dividing, add 1. And then we'll take this number and raise it to the 24th power. Let's continue this on another slide. Okay, we took 1.0225 to the 24th power. And that is giving us this decimal here. Notice how we're not rounding yet. We'll round at the very end. And that's because we don't want error in our calculations, or fewer errors in our calculation. We take this number, then multiply it by 1,800. And here we go. So after 12 years, the investment will be worth about $3,070.38. That is really good for an investment that started at $1,800. Remember, that's how much we had invested. We invested $1,800, and after 12 years, you end up with having $3,070. Let's take a look at the 2 examples we had for the simple interest and the compound interest. Remember, the simple interest only gave us $1,350, but the compound interest for the single sum gave us $1,403. Why is it that we got greater money when we invested the same amount for the same rate in the same years? And it was just either compounded or simple. Well, by reinvesting the interest earned, the interest payment keeps growing as interest is compounded on interest. So remember, it gets larger, then you reinvest, larger, reinvest, which is why compound interest is much better. So let's say for the compound of remember the compound interest for a single sum was 1,403. Let's say we took that same amount and we ended up doing it for compounded interest over time. We actually end up with a greater amount of money, $5,757. And to make the most of your money, utilize compound interest and continue to invest. So this is what we've learned from the lesson. Let's go and take a look at some scenarios where we can compare which one is better. So here's some further proof of why you should invest money and then keep reinvesting it. The number of times investment is compounded has effect on your return. Interest compounded frequently will yield higher returns. So if you did it daily, look how great it is daily versus how it would be annually. And just to give you another example why it's good to invest and then reinvest. And maybe you want to go ahead and just write down which is better. Which would you choose? An investment earning compound interest or an investment earning simple interest? Remember that your largest return is on the compounded interest, so you want to go with that one. Okay, what about an investment earning an interest rate of 2% or an investment earning an interest rate of 2.1%? Even though 0.1 is not much greater than 2, it definitely will end up giving you a larger return. Okay, for the summary of your notes, you should answer this question: which is better, simple or compound interest? And you were given multiple examples of both and why one is better than the other. So I'd like you to discuss that in your summary. You can begin by saying, I believe, or it has been proven, not that you believe, is that it's been proven that blank is better than blank because, and then go ahead and give me the reasons. Bring all your questions to class, please.